Okay, now we get to a bit of a challenge problem, the mixing candy problem. It talks about this guy Renard. He thought that writing two equations for problem 644 was easy. If we look back to 644, it was pretty easy to write those because they were essentially already in slope-intercept form. But here we can get some that are not in an easy form for equal values method. He wants to use two equations with two variables to solve this problem. So here's the problem. Ariel bought several bags of caramel candy and several bags of taffy. The number of bags of taffy was 5 more than the bags of caramel. So you know what? We can already write a little equation here. This is key, which is T is equal to C plus 5, because the number of taffy is 5 more than the bags of caramel. Taffy bags weigh 8 ounces each. Okay, so that word each is a clue. That's going to be your slope, because it shows a value that's sort of a rate. Every time you get another bag, that's another 8 ounces. The caramel bags weigh 16 ounces each, so we got another M right there. So each one already has that. Okay, the total weight of all the bags was 400 ounces. Okay, so that, when we talk about a total, we're talking about a Y, not a y-intercept, just a Y. So the whole thing is going to be equal to 400. Okay, so how many bags of candy did she buy? Renard lets T equal the number of taffy bags and C equal the number of caramel bags. Help him write two equations to represent the information in the problem. Okay, so we know that 400, which is the total, that's the Y, is equal to 8 times the number of taffy bags, so that would be 8 times T, plus how much for each of the caramel bags? 16. And then the caramel bags are equal to, well, they're just C right now. All right. And then we can also write the equation T is equal to C plus 5, because the taffy, the number of bags of taffy is 5 more than the number of bags of caramel. But it says, now that Renard is stuck, he says if both equations were in the form of T equals something, I could set the two expressions equal to each other. In other words, he's trying to do the equals values method to find the solution. Help him rewrite the equations to form in a form so that he can solve the problem. So here we have T equals C plus 5. So T is alone here. What we want to do is rewrite this one to get T alone. So we'll start with this. We need to get T alone. So the first thing we'll do is we'll subtract 16C on both sides. And that will get us 8T is equal to negative 16C plus 400. Let that sink in for a second. 8T is equal to negative 16C plus 400. Then to find T, we'll divide by 8 on both sides. And that will get us T is equal to negative 2C plus 50. All right. And then, of course, we already had our other equation, which is T is equal to C plus 5. All right. So the amount of taffy is equal to negative 2 times the number of caramels plus 50, and the amount of taffy is equal to the number of caramels plus 5. So we can use equal values method here by setting negative 2c plus 50 is equal to c plus 5. And that's exactly what it tells us to do in step C. Solve Renard's system of equations to find the number of bags of caramel and the number of bags of taffy that Ariel bought. Use the equal values method. Okay, so we set our equation. We basically say negative 2c plus 50, right? It's that expression is equal to this one. And the reason we're allowed to do that is that the equal values method tells us that they're both equal to t. Of course, did something really goofy here. I should have written t equals c plus 5 here. All right, that's better. Okay, so again, the reason we figured out that t is equal to negative 2c plus 50 by converting this one until t was alone. And we figured out that t equals c plus 5 because the number of taffy was 5 more than the number of caramels. Okay, so now we're going to add 2c to both sides. That's what I see to do. Keep writing sides funny like that. And that will get us 50 is equal to 3c plus 5. So then we'll subtract 5 from both sides. This is the third time I've written that word like that. Okay, and that will get us 45 is equal to 3c. So then, of course, we'll divide by 3. Hey, I spelled sides right. Good job. And c is equal to 15. Now, we know c is equal to 15. That means the number of bags of caramel is equal to 15. We also know that t is equal to c plus 5. So we can find t like that. If t equals c plus 5, then t equals 15, because that's c, plus 5, so t equals 20. In other words, Ariel bought 15 bags of caramels and 20 bags of taffy. Now, how can we verify that the solution is correct? Very simply, we'll take our two equations, our original equations, which are this one, 400 is equal to 8t plus 16, and this one, t equals c plus 5, and we'll look for where they intersect. So I'll deselect whatever else I have here in Desmos. I'll put t equals c plus 5, and then I'll put 400 equals 8t plus 16c. It's always good to put the original version so that if you've made any errors, it'll still show up. Okay, so we're hoping that these two will intersect at a certain point. So 800 equals, this one's not graphing. Let's try it again. I think it's solving the equation instead of graphing it. 400 equals, what's it supposed to say? 8t plus 16. 8t plus 16c. Okay, it seems to be solving this as an equation rather than graphing it. So that's interesting. It is telling us that c equals 15. So let's see if that validates what we said. It does. C equals 15. So it's solving our system. So how can we do it? We can graph the system of equations. And I think it's important to say in their original form. Okay. Now this one is harder than the previous because they didn't start out in slope-intercept form. We actually had to create the slope-intercept version. Even more tricky is that the y, the original total, ends up not being the y or the isolated variable that we set equal. Instead, we had to get the t alone. So Renard, who's sort of leading our thinking here, is a very sophisticated algebraic thinker. And it's a challenging problem, but it's definitely one that can really help you with your algebraic thinking. So it's an excellent problem.